All right. Hey, everyone. So thanks so much for coming to my talk. I'm Eugene Lim, and today I'll be talking about hacking smart weighing machines. And this is a pretty exciting talk for me because how it started was pretty organic. One day I was going to a hotel, and then I went to the gym, and I looked at my weight. And obviously that's not the most exciting part, but then I realized this weighing machine could connect to the internet. I was like, why would you ever connect a weighing machine to the internet? And that kind of sparked my interest. I started doing some research, and that got me, today. And I'm very excited to talk to you about what I've found. So, just a quick introduction. I kind of go by the hacking handle Space Raccoon online. And, I do in the day, I do standard, security engineering work. But at night, I love hacking. And one of the things that I've done as a hacker is that, I started out from web, and then I went to software kind of hacking, client-side desktop applications. And one of the things that kind of always, stood out to me was hardware hacking, because it seemed like something I didn't usually do. But this is one of the ways that got me into it. I published a book-ish. It's going to come out in June 2025, from day 0 to 0 day, talking about vulnerability research, how you as, a beginner, or maybe as a, pen tester, or someone who has some kind of basic knowledge, but you want to find 0 days. How do you get from that to there, right? And I was like you, and I'm not saying I'm there, but, I just seemed like very out of reach finding 0 days. It seemed very exciting. But it's actually, there are many things that you can learn, that you can do, that are pretty much part of a standard process, a workflow that you can learn. And that's what I'm trying to communicate, both with today's talk and through my book. So what am I going to talk to you about today? I'm going to talk to you about from the perspective of who this is for, right? And what I'm hoping is that you may have had some exposure, right, as a kind of software hacker, as a web hacker, and you haven't really touched hardware before. Hardware seems like this really exciting thing, IoT, with lots of vulnerabilities out there, but you don't know how to get started, or you're thinking about getting started. So this will kind of walk through step by step how I found 2 of these vulnerabilities that led to takeovers of millions of devices around the world, and my thought process, and really just to go into the how and why of finding a vulnerability, and not just, I got some 0 days or N days and got some CVEs. So I'm going to go through that process for you. In terms of the hard topics today, I'm going to talk about 4 things. I'm going to talk about authentication, hardware authentication. When you buy a smart device, it comes from, you get from online, arrives to your door. At the factory, how is it actually being produced? How does it make sure that when it talks back, finally, to the smart IoT server, API server, it knows that it is device serial ID number 1234 and not 12345? How does that do it? What is happening at the factory when it comes to you? The second thing I want to talk about today is association. How do you associate, for example, you scan it with an app and it connects to your user account, and now it knows that device ID 1234 belongs to person A or person B. How is that being done, and why is this important? Thirdly, I'm going to talk about, just the practices, the reverse engineering, understanding these hardware devices, how you can get to know them better. And fourthly, I'm going to talk about exploiting these weaknesses. What can you look out for? Because, one of the challenges with hardware hacking or IoT devices is that, unless it's like something really big and cool like a car, when I tell someone, oh, I hacked into your weighing machine, they're like, great, now you know my weight, right? And you want to go further than that. You want to go beyond just hacking a single device. You want to hack all of them. And I'm going to talk a bit more about that part. How do you connect 3 different disciplines, hardware hacking, software hacking, and web hacking, in order to really get the impact that you want to demonstrate in the world? So let's look at some of the top smart weighing devices today. If you go to like Amazon, you're going to search for smart weighing device. There are a couple key features that you'll see. First, and the more basic one, is that you will have Bluetooth connectivity. So these tools can talk to your app on your phone, connect to the internet that way, do updates of firmware. It can sync up your health data. It can even calculate your body fat. All of these data are stored in your user profile in the application, in the mobile application, and is talking to the web device over Bluetooth. The alternative and more upgraded feature is Wi-Fi connectivity. So they don't even have to use Bluetooth to talk to your app. They can connect directly and sync to the cloud without an app in between. And so they kind of all look the same. If you kind of look at it, it's like random company name in large letters jumbled up. but they kind of look the same. And I'm going to talk to you more about why that is important later. But let me just talk about what happens when you finally order a smart weighing machine, right? So how does the manufacturer actually distinguish all of these weighing machines at the start? So in a factory, each of these devices gets a step one, which is the unique ID or secret that identifies that machine. For example, as I mentioned, serial number 1234 or whatever. And there are many ways to do this, right? The kind of like bad way is like static identifier. They just say, hey, serial number or MAC address, right? That is programmed at the start at the factory. It's included in the device. But one of the weaknesses of this is that as a static identifier, it's very fixed, right? And if this gets leaked somehow or compromised, you can't really rotate it. You can't change the MAC address that easily. In between, one of the moderate options, I would say, is that the factory can actually program a custom secret key, right? And public or private, asymmetric or symmetric encryption. It can include a public-private key pair inside that machine's memory. So all of them are programmed in the factory. While it's going through, it's going to be added into their memory. And of course, one of the best ways and the recommended best practice way is to use certificates. And that's true using public key infrastructure. There is a certificate signing request in the factory. It will generate a certificate that proves that this machine is machine 1234 and not machine 12345. And these are the ways that you can actually make them different. So the key concerns at this stage for in any IoT manufacturer, not just a smart machine, weighing machine manufacturer, is three, right? First is, how do I make sure it's not brute force? If I have a serial number or ID, if it's just really easy to brute force, that makes it then really easy to abuse or get this key that is supposed to be uniquely identifying this machine. Secondly is revocation. So as I mentioned earlier, if you're using the serial number as the machine's unique password to talk back to the web API server, if that serial number gets compromised, someone else steals it, even if you generated it randomly, then it's going to be impossible for you to get it back again, because that person now knows your uniquely generated ID. They can keep using it to authenticate as your machine, even though it's not actually the machine that is talking to it. And finally is identification, right? Because obviously, you can use public keys, certificates, and then you got to tie it back to the device ID. So you don't necessarily want to keep the two things the same. The first is the ID of the device, and secondly, the proof that this device is that ID, right? And you want to keep those separate. Those are generated at a factory and stored in your database somewhere. And then the next thing, of course, then it gets shipped to you, right? And at that point, you want to make sure that the ID stays with it. And there are a few, again, many ways that you can do it. You could have a sticker or QR code that's in the packaging of the device that includes this identifier or unique key that you can ask the person to scan, and then it will be synced to the cloud. Second is hardware storage. You can just, put it in the flash memory and just make sure that it's loaded whenever you turn the machine on. And of course, one of the more, recommended ways again is that you store these identifying keys in a trusted platform module or a secure element that is protected. Even if someone is trying to extract the flash memory and tries to read it, it's going to actually be pretty hard for them to do. I mean, most times people find a way anyway, but at least it's, you try your best, right? And finally, when you open this package, right, from the online store and you finally link it to your user ID. So, for example, if I receive this weighing machine, I download the application, I log in with my own user account on that application, and I scan the QR code associated with this weighing machine. What it does is that it could do several things, right? Over Bluetooth or local Wi-Fi, my application could talk to this weighing machine over here, exchange, the keys, my user ID, the device ID, before talking to the cloud, the server, the IoT server, right, and says, hey, these two things are now associated, right? So my user account is now associated with this device. And from then on, whenever this device syncs to the cloud, it's going to automatically update my user profile with all the data that's coming from this cloud, from this machine, and vice versa. So this is where things get tricky, things go wrong, but we'll get to that a little later. So one of the first things I thought when I was like looking into smart weighing machines is like, hey, these things kind of look the same. Even if the company's names are slightly different, they kind of are the same apps. So what's going on here? And one of the things I noticed was that they actually did come from the same Chinese OEM, original equipment manufacturer. So they're just white labeled. They're made from the same factory. But then people, they just resell them under different brand names, but it's still connecting back to the same servers in China, in US, in EU. And one of the first things I did was to then download the mobile applications that are used to sync with these different devices. So even if they're from different devices, different companies, I realized when you look into the decompiled source code, they're actually using the same code, right? And they're using the same libraries. Or even some of them were a bit smarter. It was not exactly the same company, but they ripped off the other company and then they reused the library. So they saved on all that software development effort. It was basically the same thing. They thought they could do it cheaper and better. But that's one of the key things you notice, first of all, is that a lot of this client-side software is often reused. And this also means that your back-end API server is often the same as well, and suffers from some of the same weaknesses. So this actually makes things tricky for you, because if one of these machines have a vulnerability, and maybe they patch that vulnerability, the OEM itself is still vulnerable. And that means that if you buy any other brand, any other slightly changed brand, you might not get the secure patch. The back-end server might not be secure. And so you're not actually benefiting from that focused security effort. Now, when I first downloaded the mobile applications, obviously there's a lot to look at, right? And as a researcher, you might be saying, okay, I have this mobile application, a lot of decompiled Java code. Some of it is obfuscated, some of it is not. What do I focus on? And one of the things that you could focus on at first is the local attack surface. As I mentioned, these machines communicate with you over Bluetooth. And you might be interested in the Bluetooth part of this thing. What is the protocol they use? They use custom opcodes. So basically, maybe they say opcode 1, that means that you are turning on the smart weighing machine from your mobile phone. Opcode 2 could just be like, hey, let's sync up the recent, yesterday's weather or your weight, right? And actually, this is actually something that not just security researchers are interested in. A lot of smart home automation people want to understand this and reverse engineer this, because then they don't have to use this application, the mobile application that was provided by the vendor. They can just build their own, because as long as it's talking to it with the same language over Bluetooth, it's going to work. And that's what you see with smart weighing machines, right? It does the OpenScale project that basically reverse engineered all of these smart weighing scales and made it a simple interface for you to interact with these weighing machines. But that's not what I'm actually super interested in, right? As a security researcher, while you may be interested in saying like, hey, if I pair my Bluetooth, I can actually make this thing play a special song or do something else different, right? That may not be documented in the mobile application. But that's really kind of local impact, right? You have to pair it, it's not a lot that you can do. So as a security researcher, you might actually be more interested in the web attack surface of such devices. Where and what servers are they talking to? How are they talking to them? And are these servers actually secure, right? And basically, one of the things I saw then in the mobile application, so I decompiled the Android app as you saw in the previous slides, and I was able to retrieve a lot of these API endpoints for these smart weighing machines, API servers. And some of them look pretty interesting to you. There's a bind device, which means that that's the association of the user with the device. There's over-the-air updates. That's where you can get some of the firmware. And, this was really one of the easiest wins, right? One of the first things, as I mentioned earlier, challenges is that manufacturers need to know what kind of device IDs that they use to encode in the smart weighing machine. And in this case, for this OEM in particular, what they had done was that they had used a MAC address as not just the identifier of the machine, but also their secret key. So as long as you provided the MAC address to the API server, it would say, oh, okay, yeah, definitely you own this device, and it will allow you to pair with it, even though it might not actually be yours. The only kind of defense against this was that it's actually pretty hard to brute force all possible MAC addresses, even though technically you could. It was fairly long. It took a while. So I could not actually brute force it. So what did I have to do then? So after pairing my device to the weighing machine, I also inspected all of the web calls made by the mobile application, and I noticed there was a get device info API call. And behind that, of course, was an SQL injection, very simple. Not very simple because I had to actually bypass a WEF for it, which is a particular Chinese WEF. I'm not sure if anyone has actually encountered it. It's a BT WEF. You may have or not. Hopefully, you're not dealing with that. But it's a Chinese WEF that's actually better than a lot of the commercial options you see today. So there is a mini blog post to be had about that. That was pretty interesting. So once I was able to bypass this get device info, I could actually get the device info of any device associated with this OEM. And from there, I could actually get all of this, the MAC addresses of all the devices, more than 200,000. And this allowed me to then send it as my password to the API server to say that, yes, I own this device, and pair all of these devices with my user account. Obviously, I didn't do that, and I disclosed to them, and I think they have patched it as well. But this just shows you that this is kind of like the level 1 of hacking, right? When they have done the bare minimum to, secure the device, it becomes really easy to then break it. So let's talk about where do we go from level 1, right? What's better than level 1? And this is the device, one of the devices I brought today is a Withings WBS06. So it's just another smart weighing machine. But it's by a European company and, I think fairly secure in some ways. And one of the things I started doing was that I wanted to do the reverse engineer the firmware, right? And one of the ways that you can do it is just retrieve it from the web server API as well. So as I mentioned, I reverse engineered the mobile application. I triggered a firmware update from my mobile application, and from there I was able to kind of retrieve the actual firmware file for this device over here. It beats, trying to break it open and read the flash memory, right? So this device is fairly advanced. It's Wi-Fi and Bluetooth connectivity. There's a custom mobile application, so it's not just an OEM application. It's maintained by their own engineers. And firmware was pulled from the server API. And what does that look like? Oh, I think it's a battery thing. Okay, let's hope it works. Wait one sec. Yeah. Do you want to put... Okay, I think we need a pen for that. It's okay. I'll just, yeah. Okay, I'll keep talking here. So one of the first things is trying to reverse engineer the firmware, right? And that's kind of difficult because for anyone who's tried to reverse engineer ARM bare metal firmware before, it's incredibly hard. Right? Yeah, that's not me. Yeah, there you go. Cool. So it is incredibly hard, right? And there are some pretty good blog posts by that. Barun from Atify has a pretty good blog post about how you should reverse engineer ARM bare metal firmware. But I mean, long and short, for those who have not had the displeasure of dealing with that before, is that it's not like your typical firmware where you can, use like, what was that, bin walk, right? And unpack the file system, and you have a pretty much similar standard OS, Linux OS, kind of setup. It is just bare metal. It's all machine code. Some parts of it may be SRAM, so that is their volatile memory, so you don't even know where these pointers are going, unless you have some understanding of what the chipset is, and you read the tech specs, and you actually implement that in Ghidra. But of course, I think one of the things that can always happen is that you have strings, right? And while I was decompiling and analyzing this in Ghidra, I did see some pretty interesting thing. Why is there a shell built into my weighing machine? Why does my weighing machine, an ARM bare metal machine, need a shell, right? And so that did spark my curiosity, and I decided to start looking a bit more into this. So when I started Googling about it, I actually found that another Redditor had come across this in a previous version of this hardware before, right? Where they had talked about this. They had, talked about the shell, how it was possibly a serial port. So I decided to do an OSINT search to understand it a bit more. And if you're doing any kind of like research on connected devices, whether that's Bluetooth or Wi-Fi, it's actually a good chance that it has been submitted for the US FCC certification. That's just a certification to allow it to be sold overseas, where they have to analyze the wireless connectivity of that device. And this is, lots of documents. It includes PDF files of the internals of these machines. It shows, pictures of what they look like inside. So it saves you a lot of time of having to actually open it up yourself before you try to buy and analyze this device for yourself. Because one of the challenges with hardware research is that it's pretty expensive. You have to buy the devices to analyze them. And it would help a lot more if you had some information before doing that. So as mentioned, the Reddit post had suggested that there was likely a serial port shell, right, that you could connect. So for those of you who have not encountered serial ports before, it just means that, it's just 3 pins, transfer, receive, and ground pins, that allow you to kind of chat with this, and create a shell directly in a sense, with the machine. And what I saw from the FCC documentation were 2 interesting photos. So first was, of course, the exterior, right? And it showed these 3 pins at the bottom of the machine, and it's actually over here as well. You can take a look after the talk. The second thing that was interesting was over here, right, where they showed the internals of the chipset, and you could see the 3 pins, corresponding to the exterior. Also being over here, and you can see this is the button, right, over here, and these 3 pins match this over here. And then there are very interesting labelings here, so it's not clear on the screen, but it says ground. I think this is RX, which is receive, and then TX, right, which is transfer. So that kind of almost confirmed to me that there was very likely the same serial port available on this new version of the weighing machine, and that would be worth looking at. Another thing that's helpful when you look at these documentations is that you also get, a lot of their part IDs, right? So in this case, you look at the other side of the chip, you would see, for example, what the MCU is, the processing unit as well. And this would then allow you to get the tech sheets, right? You just search it up online, you search this number online, you'll be able to get the exact part ID model number, the technical specifications, such as the memory map, right, of where things are laid out for this chip. And this will also aid you in, for example, when you're using Ghidra to reverse engineer the device. So that's what I did. I bought the machine. I bought the things I wanted to do. I was very excited. It's my first time really doing hardware hacking. And it was actually really hard. And I realized there were 2 problems that I've encountered. Firstly, I bought crappy equipment. I ran out and just went to the electronics store and got myself a TTL to USB serial connector. And this was a very cheap version. Then I realized that was actually what was giving me all these inaccurate readings. It seemed like I had actually gotten the correct, what we call the baud rate. How the frequency of how we should be communicating with this device, over serial. And in fact, when I did go back and got myself an FT232, which is a much better chip, a bit more reliable, I was able to then communicate effectively with this machine. So I'd like to do a quick demo at this point. I recorded a video just in case it wasn't working, but I think it's working. So we'll see if I can get it running on a live demo and hope that the demo gods are very nice to me this time. So in case, you probably can't see it actually, so I'm going to just take this out and hold it up for a bit. So what I've done is gotten my serial TTL to USB connector, and I'm going to connect it to the weight machine, and we'll see what happens when I power it on with this connected. So give me a couple of seconds. Okay, so I started the terminal, and a couple of guys today some of the speakers. We were trying to fix this morning, and hopefully it's still working. If not, there's always a video. Okay, I'm missing a... Oh, there we go. Yeah, okay. I think I'll try to use this one. Okay, so I'll try to use this one first. So I'm going to restart this. Okay, so the demo gods are not going with me today. I'm going to try one more time, and I'm going to show you the video. Okay, so it didn't work this time, so we're going to use the video for this. Essentially what I was trying to do was that when I booted the device, it would actually detect the open serial connection and then trigger the... Oh, it's back. Yeah. And then trigger the shell.
I've started a multi-terminal with the correct frequency, and simply by starting the WBS05, first I'll make sure the pins are in place, connected properly, and I'm going to turn it on by putting in the battery. And you can see on the screen here, we're starting the bootloader, just checking the firmware, and there we have it, a debug shell. And simply by typing out, you will have a list of commands that will allow you to explore the rest of this machine.
All right, so that was kind of a best effort. So I'll try to talk through what was going on, right? So after connecting it, you actually get a debug shell, which was literally a shell, right? Which is kind of weird because you're wondering, while a debug shell does make sense, why do you have this on a smart weighing machine of all things? And there were actually a lot of interesting commands once you got this shell built into the firmware. For example, you could read and write to memory. You could trigger Bluetooth connections, read the Wi-Fi connection, trigger specific debugging modes, and also extract the stored secrets, which included, for example, the public and private key that was built into the machine from the start. So, yay, mission accomplished. Actually, there was still more to do as well, because as I discussed earlier, this isn't all of it, right? You hacked one machine, you maybe got the certificate signing request and the public and private key. That means you can authenticate to the servers as that machine, which is great. But, not awesome, because, I bought this machine, I can authenticate as my machine. Cool. There's nothing really special about that. So what is actually pretty cool was then when I started to analyze how it paired the device with my user account when I used that mobile application. And there were actually two flows that could work. It could be from the user app or the device, and I'm going to walk through what those were. So from the device, if you had connected it to the Wi-Fi previously, it would actually connect to the API server, present the certificate stored in it in order to, start the authentication. It will use the secret stored on it to sign a nonce provided by the server API, and then exchange it for a device session token. Whereas for the user app, it's a lot more straightforward. You just log in with your username and password, and your mobile app, will talk to the app server. The app server will give you a user session token. So keep in mind there are two different tokens at play here. So this is a bit small. I'm going to walk through it again. And what happens when you associate a user with a device? What does it actually do? Right? The device would take the session token. It would fetch the user session token from my app over Bluetooth, and then it will send a request to the API server with both tokens as well as the user that the device wants to associate with. Meanwhile, for the user flow, what the user would do, of course, is that in your app, you already have the user session token. It would talk to my device over here when fetches device session token, and then it will send both again to the API server with the device ID that the user is going to be paired with. So keep this in mind, right? Because when I analyzed the business logic and tested it, I realized there was actually a problem, right? While you had this option here and that option for the user app, what happened if you actually use the same session token, right? So you just provide, when you say device ID session token, you give it the same session token. When it says user session token, you also give the same session token. And I realized if that you only use a user session token for both authenticators, but you provide a device ID, the API server would just allow you to connect to that device ID provided. So this means that you didn't actually need the device, nor do you need it to be authenticated with the server. You only need it to be authenticated as a user to the mobile app, through the mobile app, to the app server. And you just could give it a numeric device ID, and it would happily accept that and allow you to pair with now more than 1 million devices. And after I did some investigation, I realized it wasn't just weighing machines, right? There are, heart rate monitors, I think blood pressure monitors, a lot more health devices were actually using the same server. And this allowed me to then pair it and take over all of the devices, read their information, and also write false information to these medical devices. So I was a terrible person because I found this on 29 December, over Christmas/New Year's break. But, it was serious enough that I think it was to their credit that they patched it within, 3 days or 4 days, right? And this was really a good demonstration of their security practices because they understood the severity of it and they patched it. They did have their own bug bounty program, but for me, I just, told them directly over email. So I'm going to wrap up. I think I'm close to it. There are a few takeaways I want to talk about here, right? As a person looking into device hardware hacking, there are many goals that you can pursue, right? You could try to get a shell on the device, which is one step. You could be trying to reverse engineer how it works, which is another thing. And the third is, one of the things I'm pretty interested in is IoT connectivity back to the API servers. How does it do authentication? And this allows you to then not just hack one device, but all of them. So for a software person turned hardware hacker, this are the things I learned, right? First is to understand your goal, right? Is it just to get a shell, or do you want to hack something else? Next is to think about how you're going to get there. Try to work backwards from there, right? What do you need to look at? Which attack surfaces? Is it the mobile application? Is it the server API? Is it the firmware itself? So you focus your search and you don't get lost in the very, very big attack surface of a hardware device. And once you've actually found the sinks, so you have found for example, the API call that performs the authentication, then you try to work backwards on how you're going to exploit this, whether from the web or through a mobile application. So I hope that has been kind of an interesting sharing for you, how, I kind of bought this machine one day, went to the gym, looked at my weight, but then found something else more interesting than my weight, which was a Wi-Fi connectivity. And as a pretty new person to hardware hacking, was able to kind of learn and kind of feel my way to actually finding a pretty serious vulnerability. If you want to just stay connected, you can just look up Space Raccoon online. I have a blog, X, and I think some other social media. And stay tuned. I'm happy to talk to you about anything else at the sidelines of this talk. So thank you.